Good day, everyone. Today we are going to talk about GLONASS, or the Global Navigation Satellite System. GLONASS is one of the satellite-based navigation systems established by Russia to determine global positioning of an object. Its history is it was developed by Soviet Union as an experimental military communication system. So when the Cold War ended, the Soviet Union recognized the abilities of GLONASS. The first GLONASS satellite was launched in 1982, and the system was declared fully operational in 1993. However, the GLONASS performance was declined, so the Russia brings its system up. Currently, GLONASS system consists of 3 circular orbits and 24 satellites. GLONASS satellites have evolved since the first ones were launched. The latest generation is GLONASS M.
So the GLONASS system design provides constellation visibility to a variable number of satellites depending on your location. A minimum of 4 satellites in view allows the GLONASS receiver to compute its position in 3 dimensions and to synchronize with the system time. So GLONASS satellite segment is consists of 24 satellites in 3 orbital planes with 8 satellites per plane. So each orbital plane contains 8 equally spaced satellites. One of the satellites will be at the same spot in the sky at the same sidereal time each day. And each satellites are placed into normally circular orbits with target inclinations of 64.8 degrees and an orbital radius of 19,140 kilometers, about 1,060 kilometers lower than the Global Positioning System satellites. The GLONASS satellites signal identifies the satellite and includes the following: the positioning, velocity, and acceleration of information for computing satellite locations. It also includes satellite health information, offset of GLONASS time from UTC, and the coordinated universal time in Russia, and lastly, the almanac of all other GLONASS satellites.
Alexei Leonov, Soviet astronaut, talking about his historic 1985 spacewalk. The GLONASS control segment consists of the System Control Center and a network of command tracking stations across Russia. The GLONASS control segment, similar to that of GPS, monitors the satellite's health, determines the ephemeris corrections as well as the satellite clock offsets with respect to GLONASS time and UTC, or Coordinated Universal Time. Twice a day, it uploads corrections to the satellites. GLONASS signals have the same polarization as the GPS signals and have comparable signal strength. The GLONASS system is based on 24 satellites using 12 frequencies. The satellites can share the frequencies by having antipodal satellites transmitting on the same frequency. Antipodal satellites are in the same orbital plane but are separated by 180 degrees. The paired satellites can transmit on the same frequency because they will never appear at the same time in view of a receiver on the Earth's surface.
That's all about GLONASS. Thank you for listening.